Hey guys, welcome back for another SVSU Math and Physics Resource Center tutoring video. My name is Brendon. I'm going to be your tutor. And in this video, we're going to be still using power series to represent functions, but we're going to throw in a little bit of calculus too. So that's going to be integration for this video. All right, hope you guys enjoy. Alright guys, so to start out with this video, what we're going to do is we're going to jump right into an example. And so for this example, what we want to do is we want to write the power series representation of the integral of this function that I have written. So the way that we want to do this is we first want to write this function as a power series representation, just like we did in the last video with the other example that we did. But we then want to take the integral of that power series representation. So the first part of this video, we're just going to go kind of just doing another example of writing this function as a power series. Okay, so to start out doing that, what we're going to do is we're going to pull out this x to the fourth, and then we're going to also pull out a 9 here. So we're going to pull out a 9 out of the denominator. And then so then what we're left with is going to be a 1 over, and then it looks like we're going to be a 1 plus x squared over 9. Okay, and then so we want to get this into the form of what a geometric series converges to. And so then what we want to do is we need to make this a minus sign. So that the way we can do that is just by doing like a double negative sign. So I have x to the fourth over 9, 1 over 1 minus a negative x squared over 9. Okay, so then this piece here, what we can do is we can write this as a power series representation like we did in the last video. So this is going to be x to the fourth over 9 times the summation as n is equal to 0 to infinity of, it's going to be negative x squared over 9 to the n. Okay, so now what we want to do is we want to just bring everything inside of the power series representation. So then this is going to be, we can split out, actually for this step I'm just going to be simplifying inside of the power series. So we have x to the fourth over 9, and then the summation of n is equal to 0 to infinity. And we can have a negative 1 over 9 to the n, and then we can have it looks like, let's move this x squared, so this is going to be x squared to the n. And then I'm actually going to break this up into two separate terms. So we'll have a negative 1 to the n, and then a negative 1 over 9, or a positive 1 over 9 to the n. So this is going to be equal to x squared over, or sorry, x to the fourth x to the fourth, and summation as n is equal to 0 to infinity of a 1 over 9 to the n, negative 1 to the n, and a x to the 2n. Okay, so now we can bring our x to the fourth inside and combine it with our x to the 2n term, and we can bring our 1 over 9 inside. So this is going to be equal to, let's see, the summation as n is equal to 0 to infinity. Looks like we're going to have 1 over 9 to the n plus 1. And then we'll still have our alternating term. So this is negative 1 to the n. And then we'll have x to the 2n plus 4. Okay, so this is our power series representation. But remember at the beginning, what we want to do is we want to write out a power series representation for the integral of h of x dx. Okay, so then this is going to be, if I know that h of x is equal to this power series, I can plug this into the integral here. So this is going to be the integral of the summation as n is equal to 0 to infinity of positive 1/9 to the n plus 1 times negative 1 to the n times x to the 2n plus 4 dx. Okay, so remember for the integral, what we're doing is we're integrating with respect to x, but our summation is with respect to n. So what we can do is we can take the integral inside of the summation. So this is going to be the summation as n is equal to 0 to infinity of the integral of 1 over 9 to the n plus 1, negative 1 to the n, and then we still have our x to the 2n plus 4 dx. Okay, so now we want to integrate this with respect to x. So with respect to x, this 1 over 9 to the n plus 1 is a constant, and then this negative 1 to the n is also a constant, right? So those can be pulled outside of the integral. So this is equal to the summation as n is equal to 0 to infinity of 1 over 9 to the n plus 1, negative 1 to the n, times the integral of x to the 2n plus 4 dx. Okay, so now we just want to integrate this like we would do another or a normal type of integral where we just raise the power by 1 and then we divide by the new power. So this is going to be equal to the summation as n is equal to 0 to infinity of 1 over 9 to the n plus 1 times negative 1 to the n. And then so if we raise the power by 1, it's going to be x to the 2n plus 5, and then we divide by the new power. So we'll have x to the 2n plus 5 divided by 2n plus 5. And then we'll have to add a constant term on, but we'll do that outside. So this is going to be c plus, and then I'm going to rearrange the inside. So it's going to be the summation as n is equal to 0 to infinity of, let's see, how do we want to write this? Let's go ahead and, yeah, I think we're just going to put all of this up in the top and then this in the denominator. So it's going to end up being a 2n plus 5. Then we'll have our 1 over 9 to the n plus 1 times negative 1 to the n times x to the 2n plus 5. Okay, and so this is going to be our power series representation of the integral of our initial function that we started out with. Okay, so in this video we showed how to integrate a power series. So remember, you just treat the terms that don't have an x in them treat them as a constant, because with respect to x they are a constant, because they will then range in terms of n. Okay, and so one thing to remember too is that the rules for writing out a power series or writing out a function as a power series still apply. The power series still needs to converge. All right, thanks for watching.